Hi everybody. This is a real good day. I get to show you about the law of sines. I'm going to just state the law of sines right away and show you how you could use it to find some angles and some lengths on triangles. First off, let me state the law of sines and apply it here. Although it does say, label the triangle at right as triangle ABC. When you do trigonometry, there's an interesting thing people do. Opposite angle A, we're going to call this side little a, as opposed to calling it side BC. You could call it BC, but we're going to often use the idea that opposite angle A we find side little a, and opposite angle B, we're going to call this side little b. And opposite angle C, yep, there we go, that'll be side little c. And the law of sines is going to look like this. The sine of an angle, the angle itself ought to have a capital letter, is to the length of the opposing side, little a, as the sine of angle B, sine of any angle, is to the length of its opposing side, little b. And let's continue with that same thought. What about angle C? Get that involved as well. The sine of angle C is to the length of its opposing side, little c. Now, we have a kind of a super proportion going on here. You don't need three of those, but they are all three equal. And this beautiful thing happens in any kind of a triangle. It need not be a right triangle. The proof of this is a wonderful thing. We might get a chance to look at it in class, but let me just say that this is a truthful statement, and watch how we could use it. We're going to use the law of sines to find some lengths in a triangle. And here in this triangle, we have this angle side relationship, and that's a valid relationship to know that triangles are congruent and that this is a valid triangle. And here's how we'll use the law of sines. Sine of 62 is to the length of its opposing side, that's 62 degrees, is to the length of its opposing side 20, as the sine of 43 is to the length of its opposing side, little b. That's the side that we're looking for here. And I'm going to look at this proportion a minute, and you should too, and then we'll be able to make a statement of how we're going to get little b. I took the time to write the calculations, but you want to look at this proportion and think, well, what would you have to do to solve for b? It's going to be 20 times the sine of 43 divided by the sine of 62. That's what I wrote right there. We might not write that every time, but now let's calculate b itself. I'm going to do that with a calculator, and I hope you'll do the same thing. Realize what things we have to pay attention to. Turn it on, and let's check that out. 20 sine 43 divided by the sine of 62. Kind of hard for you to see thus far, I apologize. That's 20 sine 43 divided by sine 62. And I come up with 15.45. I call that 15.4. I guess we'll round things to the nearest tenth. Side little b at 15.4. And you got to bet that's a pretty nice way to find the length in a triangle. And it needn't be a right triangle. We're going to give the measure of angle C. That should have been capitalized. I don't think I did, but it should have been capitalized. We're going to give the measure of angle C and use the law of sines to find the the length of side little c. This one. And you're thinking to yourself, well, these two angles, 63 and 43, that add up to 105. What does that leave for angle C? I think 75 degrees, huh? The measure angle C would have been 75, just using the triangle sum theorem. And then we can use the law of sines to figure out the length of this side little c. I'd stick with these numbers that were given and write this proportion. The sine of 62 degrees is to the length of its opposing side, 20. And we seek side little c as the sine of 75 degrees is to the length of its opposing side, little c. Now you stare at this proportion with me for a minute, and you decide how we're going to get c out of that. I know we're going to cross multiply and divide. It's going to be 20 times this, and we're going to divide by that. I'm going to make that statement right here, and then we're going to calculate with the calculator. It must be 20 sine 75 over the sine of 62. And let's figure out what that value should be. 20 sine 75. You're doing this too, I hope, over the sine of 62. I'm coming up with about 21.9. Yep. That would have been the length of side little c. 21.9. Now, just looking around at this triangle for a second, this side being 21.9, that's a little bigger than this side. And I'm opposite a bigger angle, huh? This was a 75-degree angle. And opposite the biggest angle, we ought to have the biggest side, and the smaller angle, the smaller side, and the smallest angle ought to give us the small side over here. Side little b was just 15.4. So you can use the law of sines very, very beautifully to find lengths. We can also use it to find the measures of angles. Let's take a look at that. Let me put this data in place. It tells me about angle R being 100.3 degrees. Side little p is 7. That's got to be opposite angle. Opposite angle p will find side little p. Side little r, yeah, that's going to be 10, huh? And side little q is 6. Show the setup as you find the measures of angle P and angle Q. Let's go for angle P right this time. The sine of an angle, the sine of angle R, make this statement with me, is to the length of its opposing side. I should have written 103, this is right there, excuse me. The sine of 103, 100.3, excuse me, is to the length of its opposing side 10 as, and we're looking for angle P, the sine of angle P is to the length of its opposing side 7. Let's check this proportion out for a minute. And what are we going to do with it? We're going to solve it for the sine of angle P, aren't we? I'm going to write that out. What will the sine of angle P going to look like? Now some of this stuff you won't have to write every time, but you definitely have to write this proportion. The sine of angle P will be 7 times the sine of 100.3 divided by 10. Got to write that down this time. 7 times the sine of 100.3 divided by 10. And then what do I got to do with this? I do seek the measure of angle P. I'm going to have to get a decimal for this number, and then since that is the sine of angle P, I will have to arc sine this amount. Let's see what that looks like with the calculator. I'm going to clear all the junk, and I'm going to figure out what is 7 times the sine of 100.3. Close those parentheses there. Divide that by 10. And I have this amount, 0.6887. But that is equal to the sine of angle P, and I want to know the measure of angle P, so I should arc sine that amount. Second sine. And you could type that number in, 6.6887, but if I just go second answer, then I'm going to arc sine that amount, and that angle should have been about 43.5 degrees, I hope you see. Let me make a note of that. That's the measure of angle P. Would have been 43.5 degrees. Hold that thought. Let's do that again. Let's find this time the measure of angle Q. Same idea. We're going to run it just along underneath here. We'll begin with the angle that we were given. The sine of 100.3 is to the length of its opposing side, 10. Now what side are we looking for? What angle are we looking for? Angle Q. As the sine of angle Q is to the length of its opposing side, 6. You look at this proportion. We know we want to get the measure of angle Q from this. So I would write over here, what is the sine of angle Q going to equal? If you were to solve this proportion for the sine of angle Q, you would absolutely cross multiply and divide. The sine of angle Q would have to equal 6 sine 100.3 over 10. We're going to get a decimal for that number right quick, and we're going to arc sine this amount, and we'll know the measure of angle Q. Then we got to add up these angles to see if they add up to 180. Let's make that happen. So first we should evaluate this amount. 6 sine 100.3 divided by 10. I got to close those parentheses. Divided by 10. And that gives me this amount. Now that's not the angle. That's the sine of the angle. I have to arc sine that amount. The second sine that amount. And that tells me that angle should have been about 36.2 degrees. I hope you can see. A measure of angle Q should have been 36.2 degrees. Now, let's add these things up, and I think they're going to add up as they should. I know I had an angle that was 100.3 plus this angle that we found to be 43.5 plus this other angle that was 36.2. And lo and behold, they add up just like they should, adding up to 180. The law of sines is a beautiful thing. We ought to use it to find all kinds of things. We'll work lots of questions together. It's a beautiful thing. Let's check out this guy, get a little practice. A triangle, ABC, has sides, little a is 9. Opposite angle A, we'll find side little a. Side C is 10. Side little angle C, is 80. Solve the triangle. Now, what does it mean to solve a triangle? That is, find the measure of each angle and the length of each side. We got to know everything there is to know about this triangle. Well, I've got to know the angle measures and the sides. What should we look for first? Well, I know these two sides. I'm going to have to find the measure of this angle. That's the clever thing to do with the law of sines. And if you remember how this looks, and let's make a statement using a couple of angles and their opposing lengths. The sine of 80 is to the length of its opposing side, 10. And what angle we want to know about? That's angle A. That's the sine of angle A is the length of its opposing side, 9. Solve this for the sine of angle A. Make that statement here. The sine of angle A will equal 9 times the sine of 80 divided by 10. I'm going to get that amount on my calculator and arc sine it, and then write that answer right here. I should look at 9 sine 80 divided by 10. Gives me this decimal number, but I'm not even going to write it down. I'm just going to arc sine that amount. And that tells me that angle should have been 62.4 degrees, or really close. 62.4. So now I know this angle. And I know these two sides. I do not know angle B, not yet, and I don't know the length of this side. But we can get angle B, can't we? I should add 80 and 62.4. I think I could do that in my head, but I'll just take it easy on myself. 62.4 plus 80 gives me this amount. Let's take that out of 180. And that tells me it's about 37.6 degrees for this one, huh? So I got to remember the triangle sum theorem, and then I got to get to use the law of sines, and I can find the measure of the side opposite angle B. Let's call it side little b. The sine of 80 is to the length of its opposing side, 10. Going for the length of side little b as the sine of its opposing angle as the sine of 37.6. Is to the length of its opposing side, little b. Every time I'm going to want to see that proportion. And then you can tell me what side little b would have been. But I got to see that proportion, homies. You got to show it to me. 10 times the sine of 37.6. Divided by sine of 80. So I'm coming up with 6.2. And that's enough for me. I think I know everything there is to know about this triangle. 6.2 for that length right there. I know all three sides and all three angles. That's all I had to do. But let me show you a couple of the things that I think are really good to know about the law of sines. There are lots of questions we can work, but here comes a really typical one. Make a sketch like this one. We can say these are a couple of firefighters. And they're 200 yards apart. There's Abel up here and Beth over here. And they sight to a fire somewhere in the distance. There's the fire over there. We'll make a sketch like this one. We're going to find some lengths. We know they're 200 yards apart. And they're going to have protractors. These are professionals. Beth sights to this fire and measures this angle against the line between her and she and Abel, and knows that that angle is, let's say, 54 degrees right there. Abel does the same thing. He can find the measure of this angle. He finds that to be, let's say, it's 72 degrees. And what we want to know is the lengths of these other two sides. How far is Abel from the fire? How far is Beth from the fire? We're going to need to know the measure angle F, though, aren't we? You tell me how we're going to do that. Well, we do know two angles in this triangle, don't we? This 72 and this 54. And those add up to 126. How would that leave over here? 126. Oh, that's going to leave 54 over here again, isn't it? Well, that's no good. We have to do this problem again, because this is going to be isosceles. Sorry about that. Let me start over. 54. Yeah, that's just not the kind of problem I want to do. I'm going to make another one real quick. I apologize. Let's come up with a different set of numbers than this. I don't want to have an isosceles triangle, although it would have worked, but that's not what I want to have happen. Let's say that this angle is 78. This angle is 52. All right, now those two angles are adding up to 130. That'd make this angle have to be 50 over here, huh? My goodness. Let's make it be obviously, sorry about that. I'm going to make this angle be 40. So if we got 40 and 78, there's 118, leaving 62 degrees here. That's pretty good. All right, now, here's Abel. Here's Beth. And you see some of the things I go through when I try to write a good question. And they're 200 yards apart. Here's the fire. How far is Abel from the fire? How far is Beth from the fire? So you were given these two angles. We'll add them up, subtract from 180. We can find this angle, couldn't we? Then we'll hit it with the law of sines. The sine of 62 is to the length of the opposing side, 200 yards, as, now if we want to know how far Abel is from the fire, we'll have to use the opposing angle there, as the sine of 40 is to the length of its opposing side. Let's call that little b. Remind ourselves that's little b right there. And then I got to cross multiply and divide right here. See what comes. That'll be 200 sine 40 divided by the sine of 62. That gives me 145.6. Pretty cleanly there. Side little b, 145.6 yards. Okay, let's figure out about this one. Now, should this one be bigger, this side little a? It's opposite a bigger angle, isn't it? So I'm thinking it's going to be greater than that amount right there. Let's see, and I think because this is a pretty small angle, that this will be substantially larger. Let's use the law of sines and figure that out. I'd go back to the given information, that the sine of 62, given the angles that was given, is to the length of its opposing side, 200. But now we're going to figure out about this side. I'm going to use its opposing angle as the sine of 78 is to the side little a. You look at that proportion with me. Figure what we're going to do to get the side little a out of there. And I have to multiply those two, won't I? And divide by the sine of 62. Let me do that right quick. 200 sine 78 divided by the sine of 62 gives me 221.6, I think best said. 221.6. Does that fit with the things we might have expected here? 221.6 feet. Yeah, that's the biggest of the three sides, isn't it? Opposite the biggest angle, we'd expect the biggest side. I want to do one more question with you real quick. Show you the beauty of the law of sines. I think we've seen this question a couple times recently, or a question like it, but I think we've done one with this very same set of numbers. And I'm going to make it happen a whole lot quicker this time with the law of sines than it did last time. Guy sights to a flagpole in the distance. I remember the numbers here. This was 5 degrees. And then he moved 500 feet closer, or maybe 500 yards closer, but I'm going to say 500 feet closer. He sights again. And this time the angle of elevation to the top of that flagpole is 15 degrees. And I say, now, let's find the height of that flagpole. And we did that in class a couple of times, and you've had a homework assignment like it. Pretty serious thing to do when you don't know the law of sines. But when you do, watch how beautifully this can be done. It's still a little bit complicated. First thing you got to remember is this interesting fact about the exterior angle of a triangle. That's an exterior angle of a triangle right there, huh? This angle is equal to these two angles added up. I made a big fuss about it all last semester, but now it's going to come to play. This is an exterior angle of this little skinny triangle right there. So this should equal these two angles added up. You could work it other ways, but this angle has to be 10 degrees. If that was 15, I guess this would have had to have been 165. You could add this and be, you could find it other ways, but that'll have to be a 10-degree angle. But now look what I can do. I'm going to get this side right there. I'm going to call it Z for a minute. It's not the side I want, but I can get there pretty quickly. Watch this. This flagpole is perpendicular, by the way. I'm going to use the law of sines of this little triangle. The sine of 5 degrees is to the length of the opposing side Z. Now, well, I got to know another angle. I do, as the sine of 10 degrees is to the length of its opposing side, 500. Let's cross multiply and divide right there. And I'm going to be able to get Z out of that, aren't I? I don't think you really got to write more than that. If you write that proportion and tell me the value for Z, I'm going to believe you did it correctly. I would have to go with 500 sine 5 divided by the sine of 10. And that number is 250 point, let me call that 955, just to keep links good. 250.955. And I understand usually we're going to round things to the nearest tenth, but I want to be pretty accurate this time. That's this length right there, huh? 250.955. Now, let's get the height of that flagpole. I think I can do it really quickly and easily in this right triangle. I could use, I want to know the opposite. I do know the hypotenuse. I could use the sine, couldn't I? Just a straight sine function. The sine of 15 is equal to F over that pretty big hypotenuse right there, 250.955. Equals, and now I'm going to write what the sine of 15 is right there. Sine of 15, I have found to be 0.2588 over 1. Both of these are equal to sine of 15, so both of these things equal each other. So what do I got to do with that to find the height of that flagpole? And I think you got to admit, this is a whole lot quicker than the last time we did this question. See, I got to multiply those. And I've already got the 0.2588 on my calculator.